Hey there, my name is Robert Ramstad, and I was one of the group members of group PJ2C, and we were responsible for the verification of continuous online monitoring for the company EPRI. So, first, I wanted to briefly talk about EPRI. They're the Electric Power Research Institute, and they are a nonprofit organization that researches ways to improve electricity generation, delivery, and use. So, what this means is we're looking at how we can create power and get it to the public and put it in ways that I could use it or you could use it most conveniently and efficiently. So the problem we were given was in power plants or any sort of electricity generation system, there are a lot of moving parts. And so if one of these parts breaks, it could cause a catastrophic failure that would lose power and electricity to potentially millions of people. So our goal was to create a system that could recognize and detect these errors from the beginning so that instead of a catastrophic failure, it would raise a flag and then we would be able to go fix this error before it created a big problem. So the first thing we needed to do was to simulate a power plant generator on a workbench. Now we created a fairly simple version, and in this case, it was just an induction motor attached to some load plates. And so when it would spin smoothly, it would become the sound and the vibration characteristics were, as you would imagine, quite smooth. There were no errors going on in the whole system. However, when we implemented error, and in this case, we implemented error by attaching small bolts onto the load plates themselves to make them uneven. The vibration and sound characteristics kind of went all over the place, and it was very obvious by our sensor data that there was a problem. So in this case, we were able to detect the error before there was a catastrophic failure. So looking at our results, that we have a picture here of what our data output looked like, and we have a picture of the entire workbench itself. So as you can see, we have our 1 horsepower induction motor attached to a rod and some bearings and some load plates. And then attached to that, we have a Raspberry Pi with sensors, like I said, 2 vibration sensors, which are piezoelectric sensors, which are simply vibration sensors. And we have sound sensors, which are just microphones. So when the top 2 graphs there on the results are the vibration when it is all running smoothly versus the bottom 2 graphs are the vibration when we have the error introduced. Whenever we made the load plates uneven, the entire board started trying to move and kind of shake around just due to the fact that the load plates were uneven and were spinning at a crazy frequency. So we did reach our goal, and hopefully if we scaled up our project, we would be able to see in any sort of power plant and we'd be able to limit the probability of a catastrophic failure that we would not be able to detect early. We hope you enjoy. Thank you.